Let's solve today's daily challenge, that is diameter of binary tree. So in this question we are given the root and we need to return the length of the diameter of the tree. Now we need to first understand what the diameter of a binary tree is. So here it's the definition of a diameter is also mentioned, that it is the length of the longest path between any two nodes in a tree, right? And this path may or may not pass through the root. So you can take any two nodes and you need to calculate the longest path between them, correct? And also, what is the length of a path? It is the number of edges between them, right? Between two nodes. Now let's understand clearly what a diameter basically is. Let's say this is a binary tree that I'm given, okay? Wait. So this is a tree that is given to me. Now I want to calculate the diameter. So as I said, I can take any two nodes, right? And what I have to do is I have to calculate the longest path between any two nodes, right? So you can take any combination of nodes, right? Let's say I take this node and this node initially. What will be the path? So you are going from this node, you'll go like this and like this to this node, correct? So what is the path length here? It's 2. Because see, now I want what? Longest path, right? So I'll try to take any two nodes as such that gives me a longest path. So I can see clearly if I take this node and this node, the longest path that I'm going to get is this, correct? And in this case, what is the length? 1, 2, 3, 4. So 4 is the length, correct, of this tree. Now let us see if we get more than this 4, right, from anywhere. But you can already see that if I take this node or this node, still I'm going to get what? 4 only. So in this case the answer is going to be 4. All right, so this is the diameter of this tree, right? So we don't really care what two nodes we select. We could have selected this node and this node, still we would have gotten 4. We select, if we select this node and this node, still we will get 4. But we cannot select this and this because then we'll get 2. So maximum out of these lengths, right, path lengths, we get the diameter of the tree, which is the longest one. So I hope now what the meaning of diameter is basically clear to you. Now let us try to understand how we are going to solve this, right? How we are going to calculate diameter. Now, if you observe clearly here, now let me give you a test case where you can also understand that why they have mentioned this, right? Because what usually happens is that people try to assume that okay, the longest path is going to be through the root only, right? But that's not true. Let me show you why. Let's say I take a tree like this, right? And let's say I take a, let's say I have this particular tree, right? Now try to calculate the longest path. Okay, let me, now try to calculate the longest path for this case. If you try to, check for this, right? Let's see what we are going to get. We're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. So here the path length is going to be 9 if you go through root. Now let me go from here to here. If I consider, I'm considering this node. Let me take another pen, okay? I'm considering this node and I'm going up to this node, right? Let's try to calculate. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Wow, we get 10, right? So they have basically mentioned that the path may or may not pass through the root. So here you can see that this is the longest path, right? And it's not passing through the root. So that's basically what they were trying to indicate, that the diameter is not necessarily like this only, okay, not like this. It can be a path between any two nodes, but it must be the longest, right? You can consider any two nodes and it necessarily don't need to pass through the root. That is the thing, right? Because people try to assume like okay, it's diameter, you go like this. No, not necessarily. You don't have to go like this through the entire tree. You can also go like this from here, right? You can also go like this. So that is what is being mentioned. So I hope you have understood that second thing also. Now let us try to understand how we are going to solve the problem, right? Now if you see, what we are basically trying to do is standing at a particular node, right? We are checking how many, what is the height of the left side of the tree, okay, and maximum height, right? Here, what is the maximum height and what is the height here in the right part? And if I simply add them, will I get the diameter, right? Will I get a path? Definitely I'm going to get a path, right? I want to get this. So how am I going to get this? Considering this node, and you add the height of this side and height of this side, you're going to get diameter, right? So this is the basically this is the concept that we're going to use. And what is it? Height of binary tree. We're simply going to calculate the left height and the right height, and we'll simply add these both, right? And what we want to do is standing at each and every node, what we'll do, will go recursively, right, to each and every node, and standing there I'll try to calculate the left height and right height, right? So let me do a dry run. Let's say we have this tree, okay? Okay, let's say we have this particular tree. Now what I'm saying is stand at every node, right? You stand here, try to calculate what is the left height. So you can see the left height is 1 2 3 4 4, it is correct. And what is the right side of the right height, right? It's 1. So here you get 5. So that means 5 is the maximum, like maximum height that you can get, like basically the path length. All right, then let me stand here. Let me stand here. What it is going to be now? See, if I stand at this particular node, I'm going to get 3 from here, right? 3 from the left side and 3 from the right side. So what I'm going to get? I'm going to get 6. Let's stand at this particular node. What are we going to get? There's no, absolutely no height at the left and at the right, so we're going to get 0. All right, let's stand at this particular node. At this node, we're going to get 1, 2 from the left, 2 from the left, and 1 from the right. So in total, 3. Then if we stand at this particular node, what are we going to get? Only 2, right? Because on the left, we don't have any height, only 2. Okay. So similarly, you have to basically stand at each and every node. Here you'll get 0, 0. Here you get 1. Here what you'll get? 0. Here what you'll get? 1. Correct. So among them you get what? The maximum value. So you take a maximum diameter variable, and inside of max d you're going to store the maximum value, that is the path length. And how do you get them? You get them by using left height and right height, correct? So this is basically what we're going to do, and we're going to do it recursively. Now let's say we are writing this function, okay? So let's say I write the function. It will return int and it's find max diameter, right? Now inside of this function, obviously you're going to take this max d variable where you are going to store the maximum value, and also the root, right? Even you don't really need to take that, right? Let's you only initialize it here. Then what you're going to do is you're going to make a function for calculating the height also, right? So how do you calculate the height? See, the logic to calculate the height is basically when you're standing at a particular node, right? What you do is at that particular node, what you have to do, you have to keep go to the left and left and left, right? And to the right and right. So you go like this, and the base call is that when you reach a node which is null, so here it's null, after this node it's null, so it's going to return you 0. Then at standing at this node, what you're going to do is you're going to calculate the right height, and you are going to return the maximum 1 plus, right, maximum of what is the left height and what is the right height, correct? So then what you return from here also 0 you're going to return, right? So here you'll return 0, so you'll get 0 as the height. Then let's say if you're standing at this particular node, right? So what you'll do, you'll go here, right? After this, you know, you already have a got 0 here, right? Then what you're going to do is you're going to check for this side also. From this side, you're going to get what? 0. So 1 plus maximum of LH plus RH. What are you going to get? 1. So you get 1 here. Then similarly, if you try to calculate for this particular node, how are you going to get 3? So after this, here you're going to return 1, correct? So here you have returned 1, and after this, you're going to return here 1 plus maximum of, at standing at this particular node, what was the left height? 1, right height 0. So maximum is 1. So 1 plus 1, you're going to return 2. So 2, and here from here you're going to return 1. So this is how basically you calculate the height. So you're going to write this height function here. So you recursively go to the left side, you recursively go to the right side, and you take the maximum out of this and add 1 to it. Okay, so this is how you're going to basically calculate the height. And also you have to check the base condition as whichever node you are at, right? Whichever node you are at, if it is null, then you have to return 0, correct? So this is how you're going to calculate the height. And here inside of this function, you calculate height, left height using the height function, right height using the height function, and then you calculate the maximum, right? Store it in max d. And then what you do, you simply you return the max d that you're getting from here. And then before returning, right, you have to also make a call to the left and right side. So from the left, calculate if standing at this particular node. See, here we are not getting the answer at the root, right? When we go to the left, are we getting a longest path? Are we getting a longest path? So you have to recursively find that also, right? So you have to make 2 recursive calls. What if you go to the left? Are you going to get a longest path? And what if you go to the right? Are you going to get the longest path? And then you return the maximum out of the left and the right here. Okay. So this is basically how you calculate. Max t is basically maximum max t comma LH plus RH that you're going to get here. And also L and R here, what are you going to return? You're going to return max t here, okay? Alright, so this is basically how you are going to solve it. Now, if you see the time complexity for this, the time complexity is going to be big O of n square. Now, why is it n square? Why is it not n? The reason being, what you are doing is standing at a particular node, right? See, first of all, you are going to check for each and every node, right? The longest path. And you are also calling this height function. Now, height function is also going to iterate among all the nodes, right? Among all the nodes of the tree. So for this find max function, you are iterating n times, and inside of this find max, you are calculating height, which is also taking n number of operations because it is going to go through all the nodes of the tree, correct? So in total, your time complexity is big O of n square. So can we do it? Can we reduce it, right? Can we reduce it to big O of n? So yes, we can. And how can we? See, instead of writing this find max function, what we are going to do is we are going to modify the height function. Now, what do you want to get? You want to get, see, height you're already going to calculate, and the way the height function is, let me write the height function here. Let me write the height function. Okay. So inside of the height function, what you basically do is you take the root and you check if root is null, correct? If it is null, you return 0. This is the base condition. After that, you make a recursive call to, you calculate the left height. So left height, how do you calculate? You simply call for height of root of left, right? Root of left. And right height, how do you calculate? Height, you make a recursive call, you calculate for root of right. And in the end, what you return? You return 1 plus maximum of LH comma RH, correct? So this is the height function. This is how you calculate the height of a binary tree. Now here, the modification that we are going to do is we are going to take this max t variable here, okay? So reason being, see, we are already calculating LH and RH inside of the height function, right? So why do we need to, go and, make another function and do the same thing? We are already calculating LH and RH, and that is of the use to us. So we are going to simply store this here only. Max d is equal to maximum of whatever it already had, comma LH plus RH, and from this function you return simply the height, correct? So it is going to give me the answer. Let's do a dry run and let's try to understand. If I do a dry run, let's say we have this tree, correct? Now we want to calculate what? The maximum sorry, the diameter, right? Now let's calculate the height, right? So when we are at this particular node, what we'll do, we'll go to this side, this side, this side. So here we'll hit the base condition. So because here we don't have anything, so here we'll return 0. Similarly, here we don't have anything, so return 0, correct? According to this logic. After that, when we will come at this particular node, right? Now max d, what is max d? Max d is whatever you get from LH plus RH. So inside of max d right now is 0, LH plus RH. Okay, then when you come to this node, what you'll do, you'll return from here, it is 0, maximum of this, 1 plus maximum of this. What is it? It is 1 plus 0, right? So 1. You're going to return 1 here. Then from here, what are you going to return? From here, what are you going to return? Okay, from here we have already returned, right? We don't have any right node here. Okay, so we have already returned for this particular node. So we know here, yes, here we don't have anything, right? So we're going to return 0. So we return 0 here. This is the base condition. Alright, so what is the height? Height is 1. But now max d, what is the max d? Max d has become 1. Why? Because LH plus RH. What is LH? 1. What is RH? 0. So it's going to be 1. Now, when we are at this particular node, we have already done. We'll come to this particular node. When we'll come to this node, we'll see we have already calculated for here 1. Alright, and 1 plus 1 is what? 2. So LH is what? 2. Then let's come to RH. Here the base condition would be hit and it will return 0. Then here 1 plus maximum. Here also you'll get 0 from here. So 0, 0, 1 plus 0, 1. Then from here what you'll return? Here you don't have anything on the left side of this particular node, right? If you don't have anything, you'll return 0. So maximum of 1 comma 0, it's 1. 1 plus 1, it's 2. So it's going to return 2. Then standing at this particular node, now I know the LH and RH. Calculate the max D. So max D is going to be whatever is maximum L, comma LH plus RH. So LH is 2, RH is 2. So max D is going to be updated to 4. Then we'll come to this particular node and we'll do the same thing again. So from here we return 2. From here we'll return 3. See, we are at each and every node we are returning the height only, right? And then we'll come to the right. We'll go and calculate for right side. So for right side, here we'll hit the base condition, we'll return 0. And after that, here also base condition 0. So here what are you going to return? You are going to return maximum of this. 1 plus maximum of this, that is 1. So you get 1 from here, you get 3 from here, and then you calculate the max t. What is the max t value? Max t value is LH plus RH. 3 plus 1, 4. Right? 4 in this case also. Now, here, from here, you'll basically return the height, which is also 4. So the height of the binary tree is 4. So in this case, they match, but see, the height can be different, but the diameter is definitely going to be stored inside of this max t variable because it is calculating LH plus RH. So this is how basically this height function is going to help us. So this is modified height function, but here we are able to calculate the diameter in big O of n just by writing this, right? So you calculate the max t like this, max whatever you are getting, right? Or max path. So that is going to be your diameter. So I hope you understood it. So let us go and see the code now. See, here what we are doing is, this is the height function, right? So we are checking the base condition. If root is null, return 0. Then we are checking the left height and the right height. So how do you calculate the left and right height? You take the left side root, left node and right node. Then what you are doing is you are also passing this max t. So this max t is an addition. So this is basically modified height function. And here you are calculating what is the maximum value you are going to get inside of the max t. So that is left height plus right height and whatever is already stored in max t. Then you are here, this is the height function. Okay, so you are going to return maximum of left edge and right edge. So this is for calculating the height, but max d is going to calculate the diameter. Then inside of the main function, you're going to write, first check the condition that if root is null, then obviously diameter is 0. Then take this diameter variable, initialize it to 0. Then simply make a call to this function, right? See, we don't have to return the height. It is the diameter that we have to return. And diameter is going to be stored inside of this max t, right? So diameter, so you pass this diameter here and root. You call this height function, and this height function will calculate the max d, and then you simply return it. So this is how you have to basically solve this question. So the time complexity, as we talked about, it is big O of n. Space complexity, because of the recursion text tab, is going to be big O of n as well.